Welcome back, students. Drawing graphs was one thing, but the more important thing is how to use these graphical representation in solving questions. Now, whenever we get questions like to find the number of solutions, infinite, one solution, two solution, we use graphical representation. So, let's start. Graphical representation is used to find the number of solutions of equations of the type fx equal to gx, okay, wherein you find that fx is of different kind and gx is also different kind. Okay, so let's see how it happens and how do we really find the solutions. Now I have steps of finding number of solutions of fx equal to gx, okay, where fx is some quadratic equation and gx is another equation. Now what kind of gx equation is possible? We can have a, suppose, sine function, cos function, any trigonometric function, okay. Then second case is you can have exponential functions also, you can have logarithm functions, okay. So that means that fx is quadratic and gx is not quadratic, any function which is other than quadratic. So how to find solutions for them? So steps is, first of all we draw the graph of fx. So as we have already discussed how we can draw the graph of fx depending upon the discriminant and what is coefficient of x square. We can roughly draw the graph of fx and we can also find its minimum and maximum value. Okay, similarly we talk about graph of gx, okay, because we know how trigonometric functions and how exponentials and logarithm functions behave graphically, okay. Now then what is the number of solutions? Whatever intersection points you have, that gives you number of roots, okay. Now what do I mean by this? Suppose on one side we have exponential function like this, okay, and we have on another hand we have some parabolic function, quadratic function like this, completely below x-axis. So here you can see that there is no intersection, the solution will be 0, okay. So we will do an illustration by which it would be more clear. Now let's see here. In this question, the question says that we have to find the number of solutions, okay, how many solutions are possible that we have to find for the equation 9 upon 10 raised to the power x equal to minus 3 plus x minus x square, okay. So what I'll do is, I'll start with the left hand side. The left hand side, if I will talk about, it is a function of the type 9 by 10 raised to the power x, okay. So what is the graph for a raised to the power x? It moves like this, okay, because at x equal to 0 it is 1, so 0 comma 1, and when x is approaching infinity it is also approaching infinity, and when x is approaching minus infinity it will approach 0, okay. I hope this point is clear to you. Now this is graph for a raised to the power x, where a is greater than 0, okay. Now I will take the case a is greater than 0 and a is greater than 1. Okay, now I'll take the case when I have the same kind of graph I have to draw when a is less than 1. Okay, now when a is less than 1, so let's analyze this 9 by 10 raised to the power x. So when I will talk about at x equal to 0, definitely it would be 0 comma 1. Okay, now when x is approaching infinity, now this 9 upon 10 is a value which is 0.9. Are you getting me? Okay, so I will say 1 upon 10 upon 9 raised to the power infinity. So 1 upon infinity, so that would approach 0 in this case. And x is approaching minus infinity. So in that case, I will have 10 upon 9 raised to the power infinity, that become infinity. So my graph would look like this. Okay. Now let us analyze the graph for our quadratic function. Okay. So we have quadratic function minus 3 plus x minus x square, right? Okay. Now let's see here. I can put it as minus x square plus x minus 3. Okay. So definitely you will say that here it is minus, so a is less than 0. So parabola mouth would be downwards. I will have downward parabola. Okay. Now discriminant d. What is d here? b square 1 minus 4 ac. A is minus 1 and c is minus 3. this comes out to be 1 and minus 12, that is less than 0. So when a is less than 0 and d is less than 0, I will have graph always downwards. So I will have a graph like this, wherein 9 by 10 raised to the power x, what was its graph? Its graph was looking like this. So do you find any kind of intersection? No. That means I will have no solutions for it. Okay. If suppose graph would look like this, had it been like this, in that case you will find that there are 2 points of intersection, so they will have 2 solutions. Okay, but that is a separate case. Okay, in this case, separate case in which discriminant d would be, a should be greater than 0. That is most important. Okay, discriminant d may be even greater than 0, whatever, no problem. But then you have to find, would also be possible that if this is the discriminant a greater than 0 and discriminant less than 0 and it's just above x-axis like this. So in that case I will have no solution. So we have to draw a graph very accurately and then we can really find out that how many solutions it will have. Students, I hope you are clear with the first application of graphical representation. Whenever you have equation of the form fx equal to gx, where fx is quadratic equation and gx may be any other type of equation, and we have to find number of solutions, we just draw the 2 graphs and find the number of intersection points. But is it the only utility of this graphical representation? No. To answer this, just stay tuned with me. Have a nice day. Thank you.